Okay. So the first question we're gonna do is in the following list underline all the units that are SI base units. Oh wait, sorry, I did not put it in our PDF. Wait, we were doing AS. Okay. That's it. So it says in the following underline all the units are SI base units, kilogram and degree Celsius, not ampere. This is not an SI unit, and this is neither an SI unit. Kelvin is an SI unit. Anyway, so please check your work. Then it says this particular formula is given, and they say calculate the percentage uncertainty in value of E. And it says unit student K, calculate the value of E as this. We want to find percent, and they have already given the percentages, so we don't need to do anything. We already have the formula, so we're gonna write delta E over E equals to delta K over K plus delta M over M plus delta T over T. Okay, like that. Now you check the powers. So all of them have no power except for T, which has 2, so I'm going to multiply 2 then. Okay. So then you're going to put like 2.1%, just directly put every value. This will be 0.6%, and this will be 2 times 1.5%. Okay. So then use your calculator, take it out, plus 0.6 plus 2 times 1.5, right? So total percentage uncertainty should be 5.7%. If you have any questions, please let me know. Then it says use your answer to determine value V with absolute uncertainty with appropriate number of significant figures, which is like you already know delta E over E in percentage was 5.7%. E they've already found out to be 8.245 times 10 raised to the power 9. Right. 8.245 times 10 raised to the power 9. I think it's this thing. 8.245. Okay. And you can convert the percentage into a normal fraction. So divide by 100 would give you 0.057 and then multiply. So, yeah. 0.057 times 8.245 times 10 raised to power 9. So I'm getting a percentage, I'm getting uncertainty of something like 4.69, okay, times 10 raised to power 8. Now, the answer needs to be given in 10 raised to power 9. Even if he has not mentioned it, you should basically match the powers. Why matching the powers are important? Because then your decimal places of the uncertainty would be right. And that way you can, write the correct answer to the correct significant, because otherwise we won't be able to do it. So if you convert this to 10 raised to power 9, you're going to move the point this way. If you move to the left, it will be 0.4. So I'm going to convert this to 0.5. Let me just write it so you guys understand. 10 raised to power 9. And then I'm going to convert this to one significant figure. Uncertainty is always 1. So I'm going to write 0.5. And now, basically what happens is, this value should always be one significant figure, and this value should match, like this value should match decimal places of uncertainty. Because uncertainty is just one decimal place, we're going to just write it as 8.2 then. You're going to convert it to this. If this was 8.255, then I would have written 8.3. If you have any questions, please let me know. Anything you'd like to ask? Okay. All right. So going to the next question then, in this one, there's a direction of flow of water, and direction flow of water, blah blah. Okay, considering components of the force in vertical direction determine the tension. So tension is a pulling force. I think it should be here. It's pulling it here, this way. So tension should be two vertical components, right? Whether you make it this way or that way, it's fine. One this, one that. So this is going to be T sine of 68. That's fine. And determine tension in the wire. It says the weight of the sphere is 280. Weight of sphere is 32. Up thrust is 280. Weight is down. Up thrust is 280. Weight is 32. Okay. And we have to balance this, right? So this tension needs to be in this direction, right? Here. And here. You can make it like this as well. Tension. So this is like 68. So T sine of 68. Okay. So we want to find the tension in the wire. Now we will only use the vertical things. So this is down, and that is up. Okay, so this is an equilibrium, so we're going to write T sine 68 plus 32 equals to 280. Like that. So then 280 minus 32 divided by sine of 68. Uh-oh. First we need to find this and then divide answer with sine of 68. So that would be 267 newtons. So the correct answer for this one will be either this, or you can also write 270. It's correct SI units, I mean significant. Then for the sphere, calculate the volume. Now up thrust is given as rho g delta V, right? Now if we have the density here, 1000, okay. Up thrust was 280. G was 9.8. And we want to find the volume. So this is pretty easy. So 280, 1000. Okay, that's it. So this is 0.029. Okay.
Sir,
Yes.
for
This is
part A, I don't understand why we didn't take the resultant force.
You don't understand why there is no resultant force?
Yeah, shouldn't we subtract 280 and then 30?
Yeah, yes, you're right. This is in equilibrium. So one of the conditions of equilibrium is that the up, basically sum of all forces must be equals to zero because resultant in that is zero. Do you understand?
Yes.
So what I've done is, if this needs to be in equilibrium, that means the forces that are down and forces that are up must be equal to each other, right? So we had this force was down, this force is also down, this is up. So what I did was I added these and put it equal to this. Do you get it?
Yes, sir.
Yeah. Because it is equilibrium. If this was like in in sort of accelerating or any other motion like that, right? If there was acceleration, then I would have put it equals to a resultant force and then F equals to ma. Is it clear?
Yes, sir. Thank you.
Okay, good. So then we got this, and then it says for sphere density, we also need to. We have the volume of the sphere. Now, density is basically mass over volume. So the volume that it has that displays would be the same. The mass is because the weight was like 32 newtons, I think. Wait a second, 32. So we can put it against mg. So 32 divided by 9.81 will be equal to m. So let's find that out. Let's do it slowly. I put 33. Oh my. Okay, so this is going to be 3.262. 3.262 kilograms. You put 3.262 divided by 0.029. That is the volume that you found out. So you can divide the answer. And I'm getting something like 112. Or you could also write 110. Like, do not write this in the exam. Just write one value. Okay, so don't get confused. If you have any questions, do let me know. Then, then the center of the sphere is initially at a height of 6.2. Wahaj. So here, do I know you? Maybe not. Okay. So the center sphere is initially at a target of height of 6.2 above the horizontal surface. The speed of the water then increases, causing the sphere to move to a different position. This movement of sphere causes the gravitational potential energy to decrease by 77. Calculate the final height of the sphere above the surface bottom. Interesting. I don't think so that's very difficult. But let's do it. It's alright. So we're gonna do E equals to mgh. Mg is 32, height is h, and it's 77. We already have the mass. So we're gonna write 77 divided by 32. So this is going to be 2.41 meters, almost like that. And then with that we have 6.2 previously, and now the new height is like the change in height is this much. So the new height is going to be 6.2 minus 2.41, and that's going to be 3.8 or 79 is also. Now it says the extension of wire increases when the switch changes position. State a symbol. Y obeys Hooke's law. State a symbol equation that gives the relationship between tension and extension. Identify any other symbols you use. So you can use tension equals to kx because of the tension it was stretched, right? That's fine. And where k is the spring constant, because he has already given extension x, so we don't have to put that. Before the sphere changed position, the initial elastic potential energy of the wire was this. The change in position of wire causes the extension wire to double. Okay, calculate the final elastic potential energy of wire after the sphere has changed the position. Okay, we can do that. It's not difficult. So energy, elastic potential energy is half kx squared. K never changed because it is following Hooke's law. So energy is proportional to x squared. Okay. So when extension was x, energy was 0.65. Okay. Now, if you put 2x into this because it doubles, so energy will be, because this square, so energy will be 4 times of the original one. So I'm going to multiply 4 times 0.65. I'm going to get the answer. Well, there could be like other methods too. For that, I think you would want to assume things, and those would be longer. So, if you do not understand this, I can explain the other method as well. Okay, cool. Just remember, this can only be used if it follows Hooke's law. If it doesn't follow Hooke's law, then we cannot use this relationship at all. Now, going to the next one, show that the ball reaches the maximum height over the ground is this. So he throws it up with this velocity. So now this is an SUVAT question. Acceleration due to gravity is down, so we're going to take it negative. We want to find this accelerate 5.6. The highest at the highest point, the final velocity will be 0. This will be 9.81, and time is not given. So the best equation will be 2as equals to v squared minus u squared. Why? Because it doesn't have time. So 2 times minus 9.81. U square was 5.6 squared. Sorry, this was 0 squared minus 5.6 whole square. So S will be equal to minus 5.6 whole square divided by 2 times minus 9.81. You can cancel the minus out. It's alright. 5.6 whole square divided by 2 times 9.81. So I'm getting something like 1.6. It said 4. Eh? That's not fair. Okay, I'm getting a maximum height of 6. So how do we get 4.7? That's not
तो
fair.
1.6 plus 3.1 करेंगे ना शायद.
Oh, yes, yes, yes. इसने कहा height above the ground. Very clever, huh? Okay, okay, okay. So I'm gonna add 1.6, 3.1, so I'm gonna get 4.7. Okay, all right, good. Now the man does not catch the ball as it falls. Calculate time taken for the ball to maximum height to the ground. Now we have the height, so we're gonna use SVAT again. So you have the height as 4.7. Initial velocity will be 0 from the top because it has just started to fall and it's falling. Final is now given, right? Acceleration will now be 9.81. Why now 9.81? Because the direction of velocity and the acceleration are now in the same direction, and we want to find this. So the best equation will be S equals to ut plus half at squared. So we have 4.7. Ut will be 0 because initial velocity is 0. So half 9.81 t squared. So then I'm gonna just quickly 4.7 times 2 divided by 9.81 and under root of answer. So the time it would take to fall is 0.98 seconds. If you have any questions, please let me know. This was pretty simple except for the trick they played on me. Alright. Then the ball leaves man's hand. at time 0, hits the ground at time t. Sketch the graph to show the variation of velocity, and it says assume v is positive in upward direction. Okay, fine. So when it basically when he basically threw it, it was 5.6 at the velocity, right? So just take it like this. What is the maximum velocity? I don't know. Take it 5, take it 10. 5, 10. And the time, it says when it leaves and hits the ground at time t. Fine. We do that. We don't need time for this. Okay. Anyway, so we're going to look at 5.6. 5.6 will be, this will be 5.2. No, this will be 6, 7, 8, 9, 10, right? 5.6 will be somewhere in the middle here. And we don't know the last velocity, right? We don't really know that. We have to do the time t. We have to find the velocity, I think. To it says numerical values are not required. Okay, then we don't have to. Okay, fine. So you will have to have a velocity in the start, and then obviously when it falls, it will have greater velocity here. So initially, what I'm saying is it will go in the positive direction, and then it will fall back in the negative direction. So there will be a point where it will cross zero. So I'm going to put that, and I'm going to sketch a straight line till t. Now the reason why I've sketched a straight line here, because the gradient of this line is constant and it is 9.81 in the negative value, because down everything we take negative. The other thing I've done is I've given this like more magnitude than this one. The reason is that obviously it would take this much kinetic energy go up, but then when it goes down, it has lost all the gravitational potential energy till here, which means it will have greater kinetic energy, greater speed. Okay, just to let you know. Then it says what is represented by gradient. Oh my god, acceleration. Acceleration due to gravity. Then it says the man now throws the second ball with the same velocity from the same height as the first. The mass of the second ball is greater than the first ball. Assume the resistance is this. So the magnitudes of acceleration. Magnitude, acceleration, same. The reason is in the formula, weight, like mass, doesn't affect g. It affects weight. So acceleration due to gravity stays the same. And speed which they hit the ground, that is also same. If you notice in the equation SUV 18, there is nothing about mass. Mass doesn't affect anything. So basically, the only thing it would have affected was when the person had thrown the object with the same speed, he must have done more work to do that because he has to lift more weight, right? But other than that, with respect to the time it will take to fall and the you know uh, the velocity it will reach at the end, it has nothing to do with mass. Yes, if this was a terminal velocity question, then obviously we would have thought that the weight does affect how quickly you reach a terminal velocity. But that's different. Okay, do let me know if you have a question. Then it says state the principle of conservation of momentum. Very easy. So it says total momentum before equilibrium is equal to total momentum after equation. So this will give you 1 mark, and the second mark is writing in a closed system. Closed system, you can also write isolated system. So uh, isolated or closed system basically means that there are no unknown forces acting. Okay. All right. Wait a second, please. Okay then. So the next is basically this question. So it says, considering the components of momenta along AB, calculate theta. Along AB. Along AB means you got to find the components of each. So I'm gonna make two vectors, this one and this one for this one, this one and this one. Okay. So this is angle theta, and this is also angle theta. Right. So this will be horizontal component will be 4 cosine of theta. This will be 4.8 cosine of theta. Now, for horizontal, we're gonna make momentum equation. Afterwards, this stick, right, and they're going to this. So this is case 2 in the notes if you check. So write m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2, and take this side as positive, this side as negative. So m1 was 3 and the velocity was 4 cosine theta. m2 was 2.5 and it is 4.8 cosine of theta, equals to, afterwards they both combine. So 3 plus 2.5 is the mass, and they're moving at the same horizontal velocity, which is 3.7. Now you will be able to solve this. We got to basically find this. Anyway, so 3 into 4 is 12 cosine theta. And I don't know what 2.5 times 4.8 is also 12 cosine theta. Wow, this is cool. So then this is like 5 point, sorry, let me find that. 3 plus 2.5 times 3.7. So that's 20.3, right? 20.35. This will be 12 into 12. 12 plus 12 is 24 cosine theta. So now we got to do 20.35 divided by 24. And then shift cos inverse. So theta is going to be 32 degrees. Let me know if you have a question here. Okay. So if it was in vertical, then you'd use vertical, all the vectors vertical, horizontal. So it's basically the same way we deal with vectors, no matter how different. And then by calculation, energy state, and explain whether the collision ball is perfectly elastic or
Can you
inelastic. Yes, and okay, you can copy this down then. It's all right. Yes. Should I go forward?
yes.
Finally, for checking elastic and inelastic, we can use kinetic energy. So to check if something is elastic collision, kinetic energy before sum of should be equal to sum of kinetic energy after. Okay, that's the rule. So initially, one object had a velocity of 4, the other has 4.8. Now, interestingly, when you have kinetic energy, it doesn't really matter which direction you take, because when you take a square, direction is already removed. So it's all right. And afterwards, they have 3.7. Okay, so I'm going to use half. The mass of first one was 3, I think. 4 whole square. So I'm doing half mv square if you don't know. Half 4, this was 2.5, I think, and 4.8 whole square. This is before, and afterwards it should be half 3 plus 2.5 and multiply by 3.7 whole square, like that. Okay, so on this side we have 52.8 joules. Well, from the by the looks of it, it is inelastic, and I just want to tell you something before even I solve this. When two objects stick together, right? So generally it is inelastic, no matter what. So I think this would be inelastic as well. Yes, it is. So this is not equal, which means that you're gonna say kinetic energy before and after is not equal. Hence, collision is inelastic. Even in the MCQs, if you get something like this, if they stick together, they are inelastic. Don't take it as elastic. So that saves some time. Then, oh, uh, okay. The moment I will see, I know this is a double slit question, the two slits. So I will remember it is AX equals to lambda D question. This equation will solve everything. So now let's do this. So it says, what is meant by coherent? Coherent basically means that two sources are coherent if the waves have constant phase difference. Now, for two lights waves superposing R for difference in their path for slits. For the two light waves superposing at R, where's R? Okay, we want to find the path difference from here till here. I think we can do that. So first of all, this is the central fringe, right? So here n will be equal to 0. The bright fringe will be n equals to 1. This one will be n equals to 0.5. This one will be n equals to 1.5. Because darks are like 0.5, 1.5, 2.5, like that, right? Now what do we need? We need path difference. What is a path difference? Path difference is equal to n lambda. So n is 1.5 at r. I just looked at it, and the wavelength is 660 nanometers. So I'm going to write multiply 660. It is in nanometers, so I don't need to change it. Thank you. So 660. So the part difference is 990 nanometers. It's this simple. Okay. Now for phase difference, you do the same thing. So if you have n, you just multiply 360 with this. So we know 1 lambda is like 360 degrees, right? So then 1.5, this is 1.5 lambda, right? So 1.5 lambda will be 1.5 times 360. It is that simple. So 1.5 times 360, this will be 540 degrees, like that. So you can simply multiply n times 360 at any time to get phase difference. Anyway, so then it says calculate the distance OQ. Calculate the distance OQ. Vijaya, did you forget about it? Forget about the class? Okay, so OQ is this much. This is distance x. So between one fringe to another, this is the fringe spacing x, right? So we want to find x. We got A, we got lambda, and we got D. So you just need to use this formula. So let me just write the values here, otherwise I'll forget. Lambda is 660 times 10 raised to minus 9. Distance is 1.8 divided by A is 0.44 times 10 raised to minus 3. So this is like x equals to lambda d over A. So do remember this formula, and it will always help you solve everything they give you. I'm going to both paste it here and then try to find this. 660 times 10 raised to a minus 9 times 1.8 divided by 0.44 times 10 raised to minus 3. So this is something like 0.0027. That's good. Then says the intensity of the incident light on the double slit is increased without changing the frequency. Okay. Describe how appearance of fringes after this change from and similar to appearance before change. Okay, basically, if you increase the intensity, so by increasing the intensity, the only thing that basically matters is that now the dark fringe, if this was like this much intense before, and then dark was like zero, so let me just draw it. So this was this much intense, and then the other one was like this, and the zero. So now it will be like even more intense. But then, will it change anything respect to the dark fringe? No, because dark fringe means they're completely canceling out each other. So it doesn't matter if you have higher amplitude, that would cancel it to be zero, and if you have lower amplitude, that would also cancel it to be zero. So it doesn't really matter. So that would mean that in this question for 3 marks, I would write that bright fringes will become become brighter, and dark fringes will become no, there will be no change. Sorry, no change to dark fringes. Okay, and then it also said without changing frequency because there is no change in frequency as well. So it means wavelength is also the same, which means that the fringe spacing fringe spacing will also remain same because x is equals to lambda d over a. D is the same, a is the same. If this is same, this will also be same. That's why I've written the and I have to add the next. Yes, Ryan.
सर इंटेंसिटी इंक्रीज करने से किस चीज पे फर्क डलेगा?
Only the amount of energy coming in, nothing else. So intensity is only related to, like, intensity is related to amplitude square. So amplitude पे फर्क पड़ेगा, that's true. But will it change anything else for us? No. Okay. Any other questions?
Sir, what affects the sharpness of the fringes?
What affects the sharpness? Well, sharpness of the fringes can be affected by, in my opinion, intensity can do that. Intensity can do that. Like, you can say that increasing the intensity would cause the dark fringes to look more darker compared to the bright fringes. That's true. All right, Hiba?
Yes, sir.
Then the light of wavelength 6 nanometers now replaced by blue light. State and explain. Now, this is, who can tell me what is this range? Which color is this? Do you know the wavelength of the color 660? Which what color is represented by this wavelength? There must be something. You guys don't remember? That's very bad. So I just want to tell you, you need to remember this. So the range of visible light colors are right 400 to 700. 400 is violet, 700 is red. In the exact middle, which is like 500, that is green. Now guess which color would be 660. Can somebody please tell me that?
Orange.
Orange. Very good. So it has to be orange. You got to remember this, please. And blue is closer to violet. So what would be the lambda for that?
voltage?
Around, yeah. So before green, before green it will be blue. So it will be like 480, whatever, right? So now we know that this is like it has gone from higher wavelength to less wavelength. So basically less wavelength. So what happens is it says state and spin change must be made to two slits. The fringes separation screen same. We want to keep the fringe separation same. Now, what difference does it make? So we need to understand that blue light has shorter wavelength. Like I told you how to remember this, you should always do this. So it will diffract less than orange. Okay, 660. Right, orange, right, 60 nanometer. Now that is the problem. We need to fix it. We need to make sure that they have the same um, look on the screen, right? So we want spacing to be the same. So our formula was x equals to lambda d over a, right? Now lambda is decreased. We want this to be same. D is the same. So lambda then can be compared with a. So if you decrease lambda, what do you need to do? You need to decrease the slit separation. So to fix it, to to basically to make sure fringe spacing is same, decrease slit separation. And I can only know this from this formula, okay, by comparison. If you have any questions, please let me know. Okay, then going to the next one, electricity. So it says show that the combined resistance network is given by. Very easy. In series, I would write series current is same. So the voltage V will be equal to V1 plus V2 plus V3. Voltages are added up because they're divided, really. Then this will be I total R equals to I R1 plus I R2 plus I R3. I is common in all of them, so you can just cancel it out. And when you do, it will be I R1 plus R2 plus R3. So this is what you need to do. Okay. Okay. Then we're gonna go to the next. So for this one, it says R1 has a resistance of 6 and R2 has a resistance of 4. So switch X is open, calculate the potential difference R1. Okay, fine. If this switch is open, this means this circuit is now effectively working only like this. Okay. We want to find the potential difference across this. So the best method to do this is using potential divider formula. Now potential divider, we want to find potential V out here. So V out equals to that resistance which is there on top. So 6 divided by, you add both of them, 6 plus 4, and you multiply this by the total EMF, which is, oh my god, 8. Okay, so this is how you do it. No need to convert, I don't think so you need to convert like kilo, because the reason is that it's a ratio, so it will cancel out. So I'm getting 4.8. I think you should also get that. So this is pretty easy. And then it says switch X is now closed. The resistance of the thermistor is this. Calculate the current in the battery. Very easy. Now this is 12 kilo ohms. Okay. Now first of all, we want to find the total current. So how do we do this? It's very simple. You add both of them to find the total resistance here. So 1 upon 4 plus 1 upon 12 equals to 1 upon R in parallel. So just use your calculator. 1 divided by 12. And then you take reciprocal, 1 divided by answer. So R in this would be 3 kilo ohms. All of this is 3 kilo ohms added with series. So total resistance will be equal to 3 plus 6, 9 kilo ohms. Okay. You have the total voltage, and now we can find the total current. So V is equal to IR. 8 equals to I times, I think it was 9. I don't know. 9, yes. So I will be 8 over 9. I don't know what that is. 8 divided by 9. Oh, I made a mistake here. I'm sorry. This is like 10 raised to power 3 as well, because this is kilo, so we have to take it now. So divided by 10 raised to power minus 10 raised to power 3. So I'm getting something like 8.9 times 10 raised to power 1, 2, 3, 4, minus 4 amperes. Pretty good then. Then it says the switch X in the circuit remains closed. The temperature thermistor decreases. By reference to current in the battery state, explain if any of decrease in temperature, power produced by the battery. So if you decrease the temperature of thermistor, so decreasing temperature would increase the resistance of thermistor. If the resistance increases, obviously the current is going to decrease. Okay, so I'm going to write overall resistance increases due to increase in resistance of thermistor. Okay. Then this decreases current, and since power equals to I square R, then basically resistance the same. Resistance there, current and power you need to compare, right? The power decreases. Right? You can also write since power is equal to VI. That can also help you find this. This is pretty easy. If you have any questions, please let me know. Then the last one. State what is representative of following letters. So 137. Oh, beta negative has 0 and minus 1. Oh, R is minus 1. So then 0 minus 1. And then 137 equals to Q plus 0 plus 0. Q is 137. And 55 positive equals to S, negative 1 plus 0 is going to give me 56. That should be the answers. Now it says state the name of the class group particles that include beta and the antineutrino. These are leptons. And then particle Y has a quark composition of DDD and D represent down quark. Particle Z has a quark composition of UD and U represent antiquark. Show that the charges of Y are equal. Okay. So down is like minus 1 by 3. So I'm doing DDD now. Minus 1 by 3, minus 1 by 3, minus 1 by 3. So the total is going to be minus 3 by 3, which is negative 1 e. Now, anti-down and anti-up and down are equal to, anti-up is, basically up is plus 2 by 3, but anti would cause it to be 2 by 3 and negative 1 by 3. So the charge is going to be negative 3 by 3. So that's also minimal. Sure. Just like that. Okay. Then it says state and explain which particle is meson, which is baryon. You need to explain this. Okay. So meson is this one, particle Z, and the reason is it has one quark and one antiquark. So meson must have one anti and one normal one. Baryon is obviously Y because it has three quarks of any flavor. So any composition, three, it's a variable. And that's it. So I don't know, I found this very easy. I don't know about you guys, but let's check the uh, grade boundaries. And then I did take out grade boundaries somewhere. Okay. It is summer, right? So summer grade boundaries will find. So and then you can compare yourself where you lie right now. And then obviously the chapters you have gotten wrong, you should revise them and obviously redo them so that in the next paper that's how it's done. So like putting your paper into the Google Classroom is very important that way. Okay. So component 2 and if you've got 42 or above, that's an A, and the higher you go is better. So I guess you have, but because this was easier, so you see the grade bound is much higher. That's good. Anyways, so now I'm gonna stop the recording, but I have some questions. You may also find them important. Maham asked me those, and she randomly asks me questions.